So we've got everything installed there. We've now got a representation of our system, as it were, up here. So that's our collectors, as it like. So now about the filling and the flushing and the maintenance. Just talk us through the process.
Okay. So Chris and his mate have installed all the equipment, so we're all ready to commission it, as he said. Why do we need to put a fluid in there? I can hear you all asking. Well, what we do, we need the fluid because we want the system to transfer the heat from the panel to our thermal store of water, but we need a fluid that's going to provide protection against frost. So Solar S1 has protection down to -28, but conversely, we need the fluid to give us some sort of thermal protection because we don't want that fluid to break down at high temperatures. And a solar panel can get to something like 200 degrees C. So our fluid, again, is stable and active at temperatures in excess of 200 degrees C. So the fluid is very important. Lastly, but probably not least, we need to provide some sort of corrosion protection within that system as well, because we've got all sorts of mixed metals, which you can see. We've got copper, steel, who knows what else is involved. So we need to stop any corrosion happening, because essentially our system's going to remain efficient as long as that fluid circulating through the system is clean. How do we get our fluid into the system? Well, we use a solar flow pump, which is essentially a dosing pump, can also be used for cleaning the system. And really, we have two options. For today's demonstration, we're going to dose the fluid from the tank on the top. But the pump also gives us the facility to dose straight from a drum of chemical. And there will be applications where you do that. So on our pump here, you can see we have an inlet and an outlet marked. Here, on the outlet, we have a hose connected, which we connect up to the system inlet. That makes sense?
And it's very simple to use, isn't it?
It's very simple to do. Let me move around this side. And then we need a return because we need to circulate. We need to create a circulating system. So from the return on the system, we go to inlet hose on the top of our solar flow pump. You can't see really very well, but that hose joins what's called a dip pipe within the system, which is a pipe that drops down within the tank below the level of the fluid. And it's designed that way so that we remove any air from the system, because we want only fluid circulating through our system. We don't want air. And we really want to make sure that all air is removed, because any small pockets of air will become much bigger pockets of air once they become heated up by the atmosphere.
That's absolutely critical, isn't it?
Absolutely critical.
Yeah.
We only want pure fluid circulating. The pump is designed to circulate 27 litres a minute, which should be sufficient to treat most systems, and it's got a 5-metre head, so pretty much any domestic installation that you'll come across it will cope with. What we're going to do now is my gorgeous assistant is going to turn the pump on and dose it with Solar S1 fluid. Press the button, Mo. And you can see the air is being pushed out of our representation of a panel and being replaced by just fluid. We keep circulating until all the air is out, and you can see because it's connected with clear hoses, and also by looking into the tank and looking for any air bubbles. And you keep circulating and circulating until you see no air at all within the system. And really, how long does that take? Well, that really depends on the size of the system, how many panels, all those kind of variables.
And Rich, how often typically would you have to do this in terms of maintenance? Once a year?
Once you've commissioned it, I would just do a check once a year to make sure that the glycol, the protection level within the system is adequate. If it's fine, then leave it. If it's not, then you'll need to top up the chemical. Why do you need to check it? Well, a thing called stagnation occurs within the panel, which is where you've reached your storage temperature. So your cylinder is up to temperature, you don't need any more heat from the panel. So essentially, your fluid is just going to sit either in the header or in the panel. And it's just going to heat up. And that's when you get stagnation and degradation of the fluid. So we really want to avoid that. But if your system has been designed by people such as Kingspan, then they'll size the system so that you get that minimum amount of stagnation period.
Brilliant. Okay, thank you guys. Thank you for the demonstration.